This video is about the equality of complex numbers. If I have two complex numbers, z1 is a plus bi and z2 is x plus yi, and if those two complex numbers are equal, so z1 equals z2, so if a plus bi equals to x plus yi, then I know for a fact that the real parts of z1 must equal to the real part of z2, and the imaginary part of z1 must equal to the imaginary part of z2. And generally it's the coefficients that I'm focusing on here. So I can say, for example, that a is equal to x and b is equal to y. And so just to refer back again to what I was saying a moment ago, the real equals to the real and the imaginary equals to the imaginary. And I can use this to work out unknown values in problems involving complex numbers. So for example, I might have a plus bi equals to 4 minus 2i, and I might want to find a and b. So in this scenario, you can clearly see that a is the real part of the left-hand side of the equation and 4 is the real part on the right-hand side. And so that means that a must be equal to 4. Looking at the imaginary components then, I can see that b is the coefficient of the imaginary term on the left and minus 2 is the coefficient of the imaginary term on the right. So I can simply say that b is equal to minus 2. I might also have something slightly more complicated, like in the second example. I might have that a plus bi equals 2, and over here I've got two complex numbers multiplying together. Well, I'm not going to directly say that a is equal to anything in particular over here, that b is particularly equal to anything over here. What I'm going to do instead is I'm going to do my multiplication first. So a plus bi, left-hand side is going to stay the same, equals 2, and then multiply out the right-hand side. So I'm going to have 3 by 2 is 6, and 3 by 2i is 6i, minus 4i by 2 is minus 8i, and minus 4i by 2i is minus 8i squared. At this point, we notice that we have an I squared. Don't forget, whenever you have an I squared equals to minus 1, which is a key piece of information in complex numbers. So a little bit of a tidy up then. I'm going to say that a plus bi equals to 6. I'll just put those two imaginary terms together. Minus 2i, minus 8 times minus 1. A little bit more tidying up then. A plus bi equals to 6 minus 2i plus 8, which I can simplify to read a plus bi equals 14 minus 2i. And then after all the simplifying, I can say that, well, okay, a is the real component on the left and 14 is the real component on the right. So a equals to 14 and b is the coefficient of the imaginary term on the left and minus 2 is the coefficient of the imaginary term on the right. So b is equal to minus 2.